Okay, hi guys, welcome back to another content session, and today we're going to be looking at blockchain technology. I feel like I just need to tell you guys that you better watch this video and know this video because this is my second time recording this, because the first time I recorded it, the audio didn't record. So I of this effort just to have to go and record it again. So please watch it for the sake of my sanity. But anyways, let's get into it. So we're going to be looking at what blockchain technology is. We're going to be looking at some important terms that you guys need to know in terms of blockchain technology. Then we're going to look at a brief history of it. We're going to look through cryptocurrency, and we're going to look through Ethereum and Bitcoin. Okay, so what is blockchain technology? So it's a technology that permits transactions to be gathered into blocks and recorded cryptographically. Chain blocks in it chains blocks in chronological order and allows the resulting ledger to be accessed by different servers. Okay, so it's a very large process, large network that exists when it comes to blockchain technology. And this just talks about like the distributed ledger that is used in blockchain technology and can be accessed by a central authority of individuals or entities with no basis to trust each other. So it's used to create value or issue assets. It's used to transfer value or the ownership of assets. It's used to record those transactions. It's used to record those transfers of values or ownership of assets. And it's to allow the owners of the assets to exercise certain rights associated with ownership and to record the exercise of those rights, right? So then we're going to look at, this just talks about like some of the blockchain benefits. So it can reduce cost and complexity. It can be a trusted record keeping source. It can improve discoverability, and it's a shared trusted process. Okay. Then this looks at some of the limitations, and these two slides come into handy when you're having debates because you need to prove or disprove the validity or importance of blockchain technology. You need to know some of the advantages and limitations. So some of the limitations include the fact that it needs high performance transactions. If you have a small organization, you may not have a business network to have blockchain technology. You need to look for a database replacement. You need to look for a messaging solution, and you need to look for transaction processing replacement. Okay. Then these are like onto like a few of the terms that you guys need to know. So the first thing we're going to look at is decentralized nodes. So blockchain is the digital and decentralized ledger, like we spoke about earlier, technology that records all transactions without the need for a financial intermediary like a bank. So the concept is a system that is decentralized and networked via nodes, right? So you effectively like the people involved or like systems involved are referred to as the nodes. Then the way in which the transactions work is that blockchains are eliminating the requirement of trust among individuals for simple transactions involving accounts, balances, or ownership of properties. Okay, so the next thing we need to look at is how it works specifically. So the transactions are initiated, and the transaction is broadcasted over the P2P network, which is encrypted. Miners rush to validate the transactions, and once the transaction is verified, a new block is created and appended to the existing blocks. Okay, so this is just a little flow diagram of how it actually works. So just read through that. Then in terms of what a node, block, and hashing is. So a node is simply a computer that participates in the blockchain network, right? So it does this by keeping a shallow copy of the blockchain, which is your light chain, by keeping a full copy of the blockchain, which is your full node, and by verifying the transaction through mining. Then a block contains transaction data and other important details related to the creation of that block, such as the time when it was created and other unique information. So in order to create a block, you must have a record which you wish to store. Then in terms of a hash is a function that converts an input of letters and numbers into an encrypted output of a fixed length. So in context of cryptocurrencies like Bitcoin, the transactions are taken as an input and run through a hashing algorithm, which gives an output of a fixed length. So blockchain uses a cryptographic hash function, meaning that the output is random but deterministic. So this means that the same input will always produce the same hash. The process is one way, so the output hash cannot be used to produce the original input, right? Then in terms of what a transaction and mining is, So a blockchain transaction can be defined as a small unit of task that is stored in a public record. So a transaction is a transfer of Bitcoin value that is broadcast to the network and collected into blocks. A transaction typically references previous transaction outputs as new transaction inputs and dedicates all input Bitcoin values to new outputs. So mining is a decentralized computational process that serves two purposes: one, to create new coins or tokens to each block, and two, to confirm transactions in a trustful manner and add to existing blocks, right? So it's expensive and requires high computational power and electricity. Then in terms of how these transactions are validated specifically, so the first thing you use is your proof of work, and the second thing you use is your proof of stake. So proof of work validates transactions utilizing a resource-intensive hashing process, confirming transactions between network participants and writes the confirmed transactions into the blockchain ledger, whereas proof of stake validates blocks created by miners and requires users to prove ownership of their stake. It makes monopoly difficult and enhances security. So now we're going to look at a brief history of blockchain. So in terms of the history of blockchain, let's go through like different things that have occurred, right? So in 2008, the idea was published under the pseudonym Satoshi Nakamoto. Then in 2009, you had the start of the Bitcoin network. Then in 2010, you had your first cryptocurrency stock exchange, which launched. In 2011, 1 Bitcoin was equal to $1. In 2013, 1 Bitcoin was equal to $100. In 2014, Microsoft accepted Bitcoin. In 2017, 1 Bitcoin was equal to $10,000, right? So that's just like a brief history of the way in which it's developed over time. So it was essentially invented to prevent shortcomings of the traditional banking and contract systems, for global validation of transactions, and the separation of powers from elite systems and organizations. And then this just talks to the different versions of blockchains that you get. So you have your Bitcoin, your Ethereum, and newer technologies that exist as well. Then you have three types of blockchain. You have public blockchain, consortium blockchain, and private blockchain. So public blockchain is fully decentralized and uncontrolled networks with no access permission required. Anyone can participate in the consensus process to determine which transaction blocks are added. Then your consortium blockchain, the consensus process for new transaction blocks is controlled by a fixed set of nodes. So we already spoke about what nodes are, such as groups of financial institutions where pre-existing trust is already high. And then a private blockchain is where access permissions are tightly controlled, with the rights to read or modify the blockchain restricted to certain users. And permission to read this blockchain is restricted, okay? Then now we need to go through what is cryptocurrency. So cryptocurrency is electronic peer-to-peer currencies, and they do not physically exist. They're measured against real currencies, and they are currencies that work and can be transacted on within blockchain technology, right? So there's a large number of different types of cryptocurrencies, but we obviously know some of the main ones include Bitcoin and Ethereum. Then these are the different types of things that you could get. You get coins, you get tokens, and you get altcoins. So your coins operate on its own blockchain. Your tokens operate on an existing blockchain infrastructure like Ethereum. And altcoins are coins derived from or alternative to Bitcoin. So the majority of coins are variant of Bitcoin. So some of the concerns of blockchain, so there's a vast majority of it, so this is an important slide for you guys to know as well, to be able to use in your debate. So the fact that it's banned in some countries, so some countries don't allow for it to be used. Secondly, it's expensive to run, and to be a part of it requires tremendous amount of resources, network power, and miners are required at a constant rate. Then you have your bubble burst, the technology being overhyped and it can eventually burst, and this also ties in with the volatility of the currencies, right? So it's very risky to invest in it. It's also very complex. A lot of people find it very difficult to understand how to use it. It can sometimes be very slow and cumbersome, so to validate a transaction can take hours in some cases due to their complexity, encrypted and distributed nature. And then you have to have a vested interest, right? So more established financial institutions are not going to buy into it because they just don't need it and they don't have an interest in it. Then these talk to some of the applications of blockchain technology globally. So in terms of healthcare, financial services, and retail. So read into these things because these can come in handy in terms of examples that you need to use in debates. So just go through these things. It's quite important for the debate. that you know examples when it comes to these things, because that's how you win these types of debates, in terms of knowing examples. This goes also in terms of real estate, transport and tourism, and media. Then if we look at some of the cryptocurrency disasters, right? So this is also very important. So one of the biggest disasters that occurred in 2014 was the Gox hack, right? So it was one of the biggest disasters in the history of cryptocurrency which occurred. And at the time, it handled the Gox exchange handled around 70% of all Bitcoin transactions. So hackers got access to the exchange, and 850,000 Bitcoins, which was worth around $450 million at the time, was stolen. So the hack impacted the crypto community and led to a significant drop in the price of Bitcoin. The exchange eventually filed for bankruptcy, causing widespread panic and skepticism among investors. So in 2016, there was something else that occurred. There was something called the DAO attack. So I'm sorry, the DAO hack. So your DAO is your decentralized autonomous organization. And what this was an innovative contract platform built on the Ethereum blockchain that raised over 150 million in crowdfunding in 2016. However, in June of 2016, an unknown hacker exploited a vulnerability in the DAO's code and stole around 3.6 million Ether, which was worth around $50 million at the time, right? So the hack led to a hard fork in the Ethereum blockchain, creating Ethereum and Ethereum Classic. Then in 2016, you had your Bitfinex hack. So this occurred in around August 2016. So the Bitfinex exchange is one of the world's largest cryptocurrency exchanges, suffered a major hack, resulting in theft of around 120,000 Bitcoins, worth around 72 million at the time, right? The hack led to a significant drop in the price of Bitcoin and caused widespread panic among investors. Then in 2018, you had your Coincheck hack. So Coincheck is the Japanese cryptocurrency exchange, and they suffered a major hack resulting in theft of around 523 million NEM tokens, which was worth around $534 million at the time. So the hack led to a significant drop in the price and obviously naturally caused panic among investors, right? So notably, after a massive boom in 2017, it was also the year that Bitcoin crashed, right? So other cryptocurrencies naturally followed suit. And then in around September 2018, they all fell 80% from their highs, making it worse than the dot-com bubble collapse of 1995 to 2000. So by November 26th of 2018, Bitcoin had lost 80% of its value, going below the $4,000 mark, right? Then you also have your Quadriga CX, right? So in 2019 this occurred. So this is a Canadian cryptocurrency exchange, and they faced controversy that would lead to its fall in 2019. So reports revealed that the company's CEO, Gerald Cotton, had died, taking the passwords to the exchange Cold Wallet, which was used to store cryptocurrencies, offline with him. So as a result, the exchange could not access around $190 million worth of cryptocurrencies, causing naturally, like we said again, widespread panic among investors, right? So now let's look at these major disasters with what happened last year, right? So we looked at things that happened previously. So now let's look at what happened last year. So we had the collapse of Terra USD and Luna. So the collapse of two main stablecoins in the crypto industry, which is Terra USD and Terra, resulted in around $40 billion in investor losses. The other coin that backed it, Luna, was also affected by the collapse and has since been renamed Terra Classic. So it's important to know that a stable coin provides a secure and stable environment for investors who are usually exposed to high volatility. And Luna and Terra USD were no different. So in theory, the price of Terra USD would stay the same as it was when it was first created. So this would make it an ideal asset for crypto investors. When in around April last year, Luna was around $116 and steadily falling to a fraction of a penny, right? So this was quite important to know. Then in terms of so despite a lot of technological advancements that have occurred in the crypto industry, right, the financial problems that some companies have faced are still enormous, right? So notably, statistics by Fortune Crypto shows that fraudsters deployed over 117,000 scam tokens this year, which was like in 2022, and this was up from 41% from the previous year, right? So those are just important things for you guys to know. So let's move on to our next slide. So this is looking to what Ethereum is. So Ethereum is a decentralized platform that runs smart contracts, applications, and The applications that run exactly as programmed without any possibility of downtime, censorship, fraud, or third-party interference. While Bitcoin aims to disrupt PayPal and online banking, Ethereum has the goal of using a blockchain to replace internet third parties. Then in terms of eCash, so obviously we value eCash because it's secure, it's a single use, it's reliable, there's low inflation, and you can preserve privacy. These are some of the protocols that crypto uses in order to like protect people who actually use this. So you have blind signatures for eCash, you have retroactive double spender identification, you have restricted blind signatures, and you have compact offline eCash, right? Then in terms of Bitcoin, right? So it's important to know that Bitcoin is the application of blockchain technology, whereas blockchain is the underlying data structure which can be used for many things, including cryptocurrency, right? So the way in which the Bitcoin ecosystem works is that you have a public network in which anyone, including a malicious participant, can participate without restriction. So even though it is not organized by a central authority, it still works. So the way in which it works is that the more participants you have, the more security you're able to gain, and the more likely there's going to be an increase in your Bitcoin value. When there's an increase in the Bitcoin value, more likely you are to draw more participants. So it's just a constant cycle of like more participants, more security, increased value in Bitcoin, right? And obviously one of the main aims was to cut out like the middleman. So you have like a direct transfer of Bitcoin. Then in terms of building a consensus, right? So after a finite time, all participants are able to agree on a single stake. So for example, on who owns how many Bitcoin, right? And then sometimes you want to create witnesses. So if something is published on a public blockchain, all participants become witnesses. So this is used, for example, by OriginStamp to create a secure timestamp for documents. Then some of the key features include the fact that it's write-only, it's immutable, you have transparent data storage, decentralized, there's no need for intermediaries, the fact that there's a consistent state across all participants, they are generally resistant against malicious participants, and it's open to everyone. However, some of the challenges do include the fact that it uses a lot of energy, so energy consumption, the scalability of it, the fact that money laundering can occur, and the fact that it then becomes a personal responsibility to manage, right? And do we really think people are responsible enough to manage it, right? So in terms of Bitcoin, right? So Bitcoin can exist as two things, right? So it can exist as the token, and it can exist as the protocol. So Bitcoin, the token, is the digital currency itself, and it's a snippet of code that represents ownership of a digital concept. Whereas Bitcoin, the protocol, is a distributed network that maintains a ledger of balances of Bitcoin, the token, otherwise known as blockchain, which we've been talking about, right? So like we said, blockchain was like a publicly accessible ledger. It's ordered chronologically in blocks. It's unchangeable, and it's verified by a decentralized network of miners, right? So some of the challenges, obviously, like these are important things for you to know. It's like, how was this created in the first place? How are we able to prevent inflation? So these are questions that you need to ponder and think on in terms of like your debates, when you have debates on cryptocurrency, when you're using them as examples. Like, are these coins legit? How do you prevent the coin from double spending? What do you do in cases where the buyer and seller are unreliable people? So if the buyer pays but the seller doesn't deliver, if the seller delivers, the buyer pays but the buyer maintains the claim, then the fact that you need to rely on proof instead of trust, the fact that it's verifiable by everyone, there's no central bank or clearing house, okay? Then this speaks to some of like the policies that we spoke about earlier in terms of like what you use to safeguard people that participate in Bitcoin trading. So you have for authentication, you use digital signatures. For integrity, you use digital signatures and your cryptographic hash. For availability, you use broadcast message to the P2P network. And for confidentiality, you use pseudonymity, right? Then in terms of like the economics to it, what we see is that we formally model a cryptocurrency system according to the Bitcoin protocol, right? So a ledger of digital balances are updated in a decentralized fashion. Then you show that cryptocurrency cannot achieve immediate and final settlement to avoid double spending problems. And then you also need to evaluate the efficiency of the cryptocurrency system, right? So then this just talks to how cryptocurrency works. So you use a consensus protocol, you use a reward scheme, and you use confirmation lags, right? So let's just chat a little bit about mining, right? So it's important you guys know what mining is, right? So with mining, you're able to verify transactions by solving computational puzzles. So miners compete to win Bitcoin, similar to a lottery, and are awarded transaction fees as well as new Bitcoin. So it requires high overhead with power consumption, and it uses high-end GPUs and has somehow led to a graphics card shortage. So when we spoke about the fact that it was created by Satoshi Nakamoto, right, who is an unknown person using the alias, when the Silk Road launched in 2011, they used Bitcoin as a currency, as Bitcoin can be pseudo-anonymous, right? So the fact that no personal information is required to use Bitcoin, transactions are verified by a network, making it hard to trace. However, the blockchain is a permanent and public ledger, and the easiest way to buy and sell requires bank account information, right? So other cryptocurrencies include Litecoin, Atari tokens, Zcash, and Dash. So in terms of buying and selling, what are the things that you require? So you require a Bitcoin wallet, you require many wallets that are tied to an exchange. You have a Coinbase, your Coinbase is the leading exchange, and you buy and sell based on the current exchange value, right? So things that you can pay for with Bitcoin is on the website overstock.com, Expedia, eGifter, Microsoft, Reeds Jeweler, Greenman Gaming, Dish Network, and Newegg. So yeah, that just speaks to all of that. And yeah, so I hope you guys learned something. So we've now reached the end of this presentation, and cool. Good luck for nationals. All the best.